So today I'm going to be demonstrating how to calculate the speed of sound in air. I'm using an adjustable resonance tube, which you may or may not be able to see, but the water level is sitting about here at the moment. I've just about filled it up. I'm using a tuning fork, and this is a G note, which is 384 Hertz. And I've also got a tape measure to measure the length of the air inside the tube. So in order to calculate the speed of sound in air, we need to look at the principles of harmonics. Now, as we can see, this is the first harmonic. Now, as the wave enters the tube, it bounces off the bottom, and that's a phase difference of half a wavelength, which means that the length of the tube is effectively a quarter of a wavelength. Now, if we look at the third harmonic, by the time the wavelength enters the tube, comes down, refracts off the bottom, effectively inside the tube you've had 1.5 total wavelengths, which means that the length of the tube is half of that, so that would be 3/4 of a wavelength. Strike the tuning fork. You may just be able to hear it there. If not, as I adjust the tube, okay, so you can sort of hear that resonating there. Okay, so now that we've found the length of the tube from our first harmonic, which is going to be the distance between the mouth of the tube and the water, we're now going to measure that. So from the top down to the bottom, we can see that that is 21 centimetres. So we've calculated the length of our tube for the first harmonic to be 0.21 metres or 21 centimetres. Now remember, going back to our previous diagram, that was equal to a quarter of the wavelength, which means that the wavelength in total is 0.84 metres. Now, as we discussed earlier in class, the velocity of a wave is equal to the frequency times the wavelength. Now we know that the frequency of the tuning fork was 384 Hertz, and we've now calculated that the wavelength for the first harmonic was 0.84 metres. If we plug that into our calculator, we'll end up with a velocity of the speed of sound as 322.56 metres per second, which isn't terribly off the mark, considering that the theoretical value is roughly around about 330 metres per second anyway. Okay, so that's how we've calculated the speed of sound in air using the first harmonic. If you continue on and you extend the tube holding the tuning fork over, you'll find the next harmonic, and using the values we saw before, using the length as 3/4 of a wavelength, and using the new length of the tube, you should be able to get roughly the same answer again. Good luck with it.
Shimmy yeah, shimmy yeah. Give me the mic so I can take it away. Off on the natural charge, bon voyage. Yeah, from the home of the Dodger Brooklyn squad. Wu-Tang Killer, beats on the swarm. Rain on your college ass disco dorm. For you to even touch my skill, you gotta go